Okay, now what we're going to do is we're doing another investigation here, again a microscope investigation, and this time we're going to be looking at these cells in particular here, the stomata. Not just this pore, not just the actual hole that's allowing gaseous exchange to happen, but these two highly specialized guard cells on either side. I asked you to do some information about them, about these highly specialized cells, the guard cells, but why do you think that these are found in the lower epidermis rather than the upper of the leaf, and also just using this information presented in the textbook. This investigation is related to investigation 5.3 in your textbook on page 148 to 149. So let's get into it. And this is what I meant by putting some nail polish just on the surface of the leaf. Hey guys, while editing the video, I just realized that I didn't actually explain how we were going to do this, or at least I didn't film it. So the way we're going to do it is that you put nail polish onto the leaf, you let it dry, put it in the fume hood, drops the drying time considerably to only about 15 minutes. Once it's ready to be dried, you put sticky tape on it firmly and gently, and then you can pull it off and you should have an impression of what's going on that epidermis of the leaf. Just a little bit there. And once that's dried, we should be able to take it off with the sticky tape.
20 minutes later.
And get this nail polish off of here using the sticky tape. So gently but firmly rubbing it on there, and you can still make out the nail polish there underneath the sticky tape. Gently and firmly rub it, and when we pull, this should pull there we go, perfect. And then you can see there that we've got that like milky coloured nail polish there. That's how you know you've gotten it off. And this is the end product. You can see that milky white nail polish there, which is going to be where hopefully we see a bunch of stomatal pores. Now, just as a reminder, if you're doing any sort of comparison like we're doing here between these three types of leaf, a spinach type species, a ficus species, and a eucalypt species, it's good always to name your slides. Doesn't need to be anything too crazy. If you add more samples, you might need to develop a naming convention for your particular prac. Oops. There we go. And spinach species. There we go. We've got our slides all prepared on the microscope. They're adequately labeled for our purposes here, and actually what we've seen is this pool's actually been really nice. You can see here each of these is one stomata, okay, or stomate, sorry, many stomata, one stomate. Now the middle is the stoma, as in the actual pore that's going into the leaf. And each of these little things around it is the guard cells. When those guard cells are flaccid, it closes the pore And when they become turgid, as in they fill themselves up with water, they're able to get really plump. And what happens is they sort of go out like this, like that, as they get more full of the water, which allows that pore to open and actually for increased gaseous exchange and actually increased transpiration. As in this idea that the water needs to go from the roots out of the leaves, but we need to create that pull. So water needs to go out of the leaves for that water to actually come into the roots. And that's all being controlled by these amazing little cells called stoma. Now what you're going to do for the prac is you have to design an investigation. I'm going to give you the 3 types of leaves that I've prepared here. The ficus species, the spinach species, and also the eucalyptus species. So you can do a cross species investigation. And also, how would I design an investigation to prove that there is more stomates or stomata on the bottom of the leaf versus the top of the leaf, as in on the lower epidermis versus the upper epidermis? Can you please design a prac for me? Remember, this is in line with investigation 5.3 from your textbook 148 to 149. What I'm going to do is I'm going to include some images here, and you can use this to calculate the density of stomata. The way you do that is you count how many of these things are in a particular field of view. I'm going to give you 3 per slide, and I'm also going to give you the measurement of the field of view that's presented here to you. And you're going to work out the density, and you're going to get some actually, rather than some qualitative data, oh, it look like more, you're going to get some quantitative data to actually align to your investigation. Good luck, and make sure you send those results and keep up to date with your biology work. And just so you can see again the benefits of this video microscope, I'm able to give the actual length of each cell here. So you can see that each of these stomata are around, from what I've seen from all of them, is between 40 and about 55 micrometers. And that actually depends on how turgid or how thick or how much water the guard cells have actually taken in. So you can see that this stoma is lovely and open, ready to either do some gaseous exchange or let go of some water. And you can see that this guard cell itself is 20 micrometers in length. So if you've got the stoma plus 220 micrometers, we can comfortably get into that 50 micrometers in length of each of these stomata. Keep getting the name wrong. Sorry about that.